Hi everyone. This is another video about AWS SageMaker. My goal is to show you how to apply the SageMaker built-in algorithm linear learner to obtain a regression solution with the Avalon dataset. I know many of you are familiar with the Avalon dataset, but if you are not, that's okay because I will discuss what the Avalon dataset is about soon. Now, linear learner. Linear learner is one of the many built-in algorithms in SageMaker, and there are many built-in algorithms in SageMaker. And you can use linear learner to obtain both a classification solution or a regression solution. But as I told you in this video, I'm going to focus on a regression solution. Just in case you're interested in learning how to fit a classification solution using SageMaker built-in algorithms, I have a video in my channel where I apply another algorithm, XGBoost, to fit a classification solution. So if you're interested in that, you can go ahead and watch that video. Great. Guys, in this video, this is what I want to accomplish. I'm going to show you first, how to download the Avalon dataset from S3. S3 stands for Simple Storage Services. Sorry, singular, Simple Storage Service. And it's just simply an AWS service that allows us to store files, okay? Very widely used AWS service. So I'm going to show you how to download the Avalon dataset from S3 and then how to upload it back to S3 to a place that is accessible for training in SageMaker. That's very important, okay? Then I'm going to show you how to define a linear learner model in SageMaker. What do I mean by defining? By defining, I mean how to use the right container for the linear learner algorithm, how to define the location in S3 for the model artifact file. I'm going to explain what that is later, and how to set up basic hyperparameters. Then I'm going to show you how to train the model. Two different things: define the model and train the model. And then once you train it, I'm going to show you how to retrieve evaluation metrics, like performance metrics in the validation data, like mean absolute error, mean square error, and others. Okay. And finally, I will mention, but I will not show you, only mention how to deploy the trained model. So once you train the model, you can deploy it to a SageMaker endpoint to, and use it to make predictions of new data. Okay. But again, I'm just going to mention how to do that. I'm not going to demonstrate it to keep the video as short as possible. Okay, so um, let's jump into action. This is the thing, guys. In order to use SageMaker to do the analysis that I'm about to do, like if you want to do the analysis, if you want to replicate the analysis that I'm about to do, you need to complete a set of I would say very easy, really, preliminary steps. Now, I don't want to spend time in this video showing you how to do these very easy preliminary steps because, it would take us like probably 10 minutes to do that. So instead, what I did was I created this Google Doc, which I'm going to share in the video description with the steps that you need to follow before being able to replicate the analysis that I'm going to do. Okay. So you follow those steps, those links, and the explanations are very clear, so you will be able to get this done. Okay. Briefly, the first step is open an AWS account and start using services through the AWS console. Then you need to open the SageMaker app in the console. You need to create what they call a SageMaker notebook instance. Step number 4 is you need to open Jupyter Lab and then open a Python notebook. And step number 5, which is something that you do once you're done with the analysis, is to clean up all the AWS resources that you used. Very important that you do that, okay? And again, you follow that link and they will explain you how to do that cleanup. Okay, right now I am at step number 4. Here it is. So I already opened Jupyter Lab. This is Jupyter Lab, and I'm going to go ahead and open a new Python notebook. Okay, so let's go ahead and do that. File, new notebook. Select that default kernel that pops up, the Python 3. That's the right one. And there you have it, guys. Okay, that is your new Python notebook. Let me increase this a little bit more. This is good. All right, so Now, what I want to do is, before anything, I'd like to change the name of the notebook, okay? So I'm gonna rename it to, how to call it? Maybe something like this, Linear Learner, and the name of the data set, Avalon, okay? Cool. There you have it. Now, let me go ahead and add a few code cells to this notebook, okay? You can use that option, the plus sign, and add a few code cells there, okay? Now, I'm going to transform the first code cell into a text cell by changing from code to markdown because I want to include text in that cell. What text? Well, the description of the data set. I told you I was going to give you a description of the data set, right? Just in case you are not familiar with the data set. So I have that description in this document and a few other things, right? This document. Anyway, so let me paste them. I need to add one more space here. And this is the Avalon data set. It contains 9 fields, starting with the rings. The rings is a number indicating the age of the Avalon. So once you know the number of rings, you can get the age because age equals the number of rings plus 1.5. So usually, as they say here, usually to count the number of rings, you need to use microscopes, which is, expensive, time consuming. So the idea is, instead of using microscope, can we get a regression equation that allows us to predict rings based on other characteristics of the avalons that are easy to measure? Okay, that's the idea. So, and these characteristics are the sex of the avalon. These are the characteristics, sex of the avalon, the length, the diameter, and so on and so forth. Okay, so like physical characteristics. So in this data set, we have 9 columns. One of them is the target or outcome, which is rings, okay? And these other ones are features, okay? Notice that all the features are numeric, but sex. Sex is categorical, okay? And we need to do something with sex, supposedly, because in machine learning, all the features must be numeric in order for us to fit a model, okay? So let's see what happens with sex, okay? But the rest, all of the other features are all numeric. This one is not sex. So let's see what happens, okay? All right, so that's it with the description. So I think we're ready to load the data, okay? Let's go ahead and load the data. Let me actually convert this cell into a text cell because I just want to at least type in subtitles specifying what I'm doing so that the notebook looks a little bit more organized. So I'm gonna load the data right now, guys. I told you that the data was in S3, right? Actually, it's in a public S3 bucket in AWS, okay? What I'm going to do now is I'm going to download the data from that bucket, and then later I'm going to upload it back to S3, but to a different location, not to the same public bucket, okay? Why do we need to upload it back to S3? Well, because as you will see later, to initiate a SageMaker training job, the data must be in S3, okay? So that's why we need to upload it back to S3. Now, this is the thing. To download the data from S3, I'm going to import the Boto3 library. Let me go ahead and do that. Import Boto3. And, with this library, I will be able to create a client for the SageMaker notebook instance to talk to S3. That's what I want. I want the notebook instance to be able to talk to S3. What do I mean by talking? I want the notebook instance to be able to download data from S3, upload data back to S3, okay? I will be able to do that using Boto3 library, okay? And actually, what I'm going to do is with this library, I'm going to create an S3 client object, okay? That would allow me to do the uploading, downloading, all right? Let's go ahead and do that. So from Boto3, I'm going to invoke the function client. And I want specifically an S3 client, okay? That's what I want. So I'm creating that S3 client, and I'm going to store, obviously, that in a variable. Poly client. Maybe like a better name is actually an S3 client, okay? All right. And I'll be able, as you will see in a second, to use that client to download the data from S3, okay? Cool. Now, Oh, I know what is happening here. I think I know what is happening. Oh, come on. Yeah. Unknown service S3. I used capital letter S and it's lowercase. Okay. So perfect. Now it's perfect. I told you that the data was in a public S3 bucket. I didn't want to memorize the name of that bucket. So you need the name of the bucket to be able to access it, right? I didn't want to memorize that name. So I stored that name here in this Google Doc. Basically, in this Google Doc, I store things that I did not want to memorize. Okay, like for example, this. Okay, who wants to memorize that name, right? Nobody. So there you have it. That is the name of the public bucket where the Avalon data set is. Okay, again, who wants to memorize that name, right? So SageMaker, example, files, production, okay? And um, and then notice that to access that bucket, you need to specify the region that you are in. I am in US East, but I mean like the AWS region that we are in, okay? There are many AWS regions. So instead of hard coding the region, I'm trying to retrieve the region programmatically, which is a good idea because if someone else uses this notebook from a different region, this will work, right? If you hard code it, it would not work. Um, okay, so this seems good. Oh, notice also that the bottom three, it's also useful to retrieve the current session, like to retrieve the region name programmatically, you need a session, okay? Um, and 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 bottom three allows you to retrieve that session, okay? So okay, that's great. Good. Now what we can do is we can download the data. The data consists of three CSV files, guys. Not only one, but three CSV files. Train file, validation file, and test file. So the data is already split, okay? And that's not very common. Usually the data is a single CSV file, and then you need to download it to your notebook and then split it in your notebook. That's the usual way. Here it's not like that. It's already split. Okay, not very common, but you know, it is what it is. So we need to download each of these three files individually. All right, and that's what I'm gonna do, but I'm gonna start obviously with the train data, okay? And to download, I'm gonna use the client that I created, and I'm gonna use the function download file, okay? From that client, I'm gonna invoke the function download file, and I'm gonna download now the train file, then validation, and then testing. So this function download file takes three arguments. The first one is the bucket. Okay, what bucket are you downloading the data from? The next one is in that bucket, what is the path to the file that you want to download? That's another thing I didn't want to memorize. This is the path in the bucket to a training data. Again, who wants to memorize all of that? So I saved that in that Google Doc. Okay. And this is the second argument, guys. That is the path in that bucket to a training file. And the training file is this. That's the name of the train file. Avalon dataset1 underscore train.csv. Okay. Um, that's great. Now the third argument is how do you want to call your file locally? So when you download that CSV file, how do you want to call it? I could have called it like this. You know, I can go ahead and just use the same name, but that name is kind of ugly. I don't like that name. I would like a simpler name. So I'm just gonna call it train.csv. So how do you want to call the file locally? Okay, I'm just gonna call it train.csv. And sure enough, when I run that code cell, you'll see that here, now I have the train file downloaded, okay? That's great. So I'm gonna repeat the same thing now for A, Control C to download the validation file. So the same bucket. The only thing that changes is datasets tabular. You see Avalon train CSV is not train CSV, is validation. Is it validation or validate? Validation. Validation. And what else? Avalon dataset is not train, is validation. And obviously, I want to call this file validation. And sure enough, there you have your validation file downloaded locally, okay? Lastly, I'm gonna repeat the same thing for the test file. Same bucket, the same path initially, then here is test. Uh, Here is test, and I want to call it test. Okay, and again, there you have the file. Okay, there you have the train file. Okay, good. So we have the three files stored locally, guys. So let me go ahead and add a few more code cells. Now, what I want to do is I told you I need to download the data back to S3, right? But before doing that, I would like to explore the data, okay? I'd like to take a look at the data because, again, for example, I don't know uh, the sample size of the training data, like how many observations in the training data, how many observations in the test data. We need to know that, especially the size of the training data. That would be important for us to make one decision later, okay? So I would like to explore the data, the three data files. So one way of doing that is you convert the CSV files into pandas data frames, and then you inspect the data frames using pandas functions. Okay, so I'm going to import pandas as PD. All right, and then I'm going to do the following. I'm going to transform. Okay, I'm going to create a trained data frame using the CSV file. So I'm going to read the CSV file um, as a data frame. Okay, so I'm going to read the train.csv file as a data frame. Very important, guys. This CSV file have no header, so you need to specify that, or otherwise you get something unexpected. Okay, so no header. Okay, and yep, that should work. Okay, and then we do the same thing with the validation file. Because again, I just want to inspect them, right? Oh, another thing I want to do is, in addition to a sample size, I want to take a look at the sex, right? Or sex column. Told you that we need to take care of that sex column. So that will be interesting. And then test. Yeah, this is good. All right, now let's take a look at these files. So I'm gonna first re take a look at how many observations. Okay, how many observations in the train data. So I'm gonna use shape just to see rows and columns. I know the columns, but I knew there were 9 columns. You knew that as well, but I didn't know this. So now I know that we have 2,923 observations in the train data. Okay. All right. Perfect. How about the validation data? 626. And um, test should be the same. Yeah, 626 because uh, uh, they usually do this an 80, 20, or 70, 30 train test split, and then they split the test in half, like half for validation, half for testing. Okay. Anyway, so that is good. Now we know how many observations in the train data. And let's take a look at the sex column, right? Um, let's just, I guess, from train df, I can invoke the head function. So I can look at the first 6 rows and first five rows. And sex was the second column, right? Yeah, the first one is rings, the second one is sex. And well, when I look at the second column, which is this one, I see numbers. I see 2, I see a 3. In principle, that's good news, right? Because I see numbers. Sex is categorical, um, and I don't see categories. I see numbers. That's supposedly good, but actually, that encoding that they use is really bad. Okay, let me explain what they did. So, I mean, it's good in the sense that at least we don't have categories, like we don't have labels, we have numbers, that's good. But the encoding they use is really bad. So the three sexes, there's 3 sexes for Avalons, male, female, and infant. And this is what they did. They assign a 1, or they assign the M to a number 1. they assign F female to number 2, and they assign I infant to number 3. Okay. I did my research and I found that out. Actually, I can show you. So you don't need to trust me. So let's take a look at, you know what? Let me retrieve the first, not the first column, like the second column, which is the one with index 1. And I'm going to do a value count. So you can really confirm that we only have three, yep, three categories, like, or three numbers. Like the numbers are 1, 3, and 2. We can sort the index here, but that's okay. So the three categories, the three numbers that sex takes is 1, 2, and 3. Okay, and it's just what I told you. The encoding they did was um, 1 for male, 2 for female, 3 for infant. That is a really, really bad and really nonsensical encoding, because when you use that encoding, this is what you're telling the model or the algorithm, the linear learner algorithm. Hey, 3, which is I, 3 is more or higher than 2, which is female. And 2, which is female, is more or higher than 1. We don't want that. We don't want the algorithm to understand an order like that, right? Because, for a feature like sex, we only need the algorithm to know that the three different categories represent different conditions with respect to sex. But we don't want the algorithm to use the order implicitly capturing these three numbers, okay? Because think about sex. In sex, we don't have that ordering. Like we don't want the algorithm to think that I, which is infant 3, it's more than 2, and then 2 is more than 1. Okay. Uh, Again, 2 is female and 1 is male. That doesn't make any sense. Okay. So this is what we should do, guys. We should apply a better encoding. For example, one hot encoding. Okay. So here, if this was like a real life example, I would apply one hot encoding to get 3 binary variables, like 1 for infant, 1 for female, 1 for male. Okay. And that would be the right way of transforming that categorical qualitative column into 3 numeric columns. Okay, but this encoding is not good. Now, guys, I don't want to spend time applying one hot encoding here in this video. It's gonna take me like 5 minutes, so I'm just gonna leave the encoding like that. But again, you should know that this encoding is not good. It's not correct. So we should actually apply one hot encoding. Okay, but again, guys, in this video, I want to focus on showing you how to apply linear learner in SageMaker. Okay, so I'm gonna skip that transformation. Okay, cool. Now that we know the size of the training data, test data, validation data, and we know what's going on with sex, we should now upload the data back to S3. Okay, and that's what I'm gonna do now. Upload the data back to S3. So let me add one more subtitle here. Markdown text. Just specifying what I'm doing. I'm gonna upload the data back to S3. Let me add a few more code cells here. Enough, so I don't need to add more code cells. And yeah, let's go ahead and do that. So I will upload the 3 CSV files where to a SageMaker pre-built bucket. Okay, and this is what you should know. SageMaker always has a bucket available in S3, and we call that bucket the SageMaker default bucket. Now, to access that SageMaker default bucket, we kind of need to do it as part of an active SageMaker session. To be able to access the current SageMaker session, we need to import the SageMaker library. So right now, what I'm going to do is I'm going to first import the SageMaker library so that I can access the current SageMaker session and then the default bucket. Okay. Now, SageMaker is going to allow us. This library is going to allow us. Sorry. Not only to let me run this first. So important SageMaker will allow us not only to access the current session. Obviously, with SageMaker, we're gonna be able to run the training job, uh, to create an endpoint for predictions if we want to. So SageMaker will allow us to do a lot of things. Okay, a lot of important things that we need to do. Perfect. These guys, this is just a warning, okay? So this is not an error, so you don't need to worry about that. This is just telling me that my current SageMaker version has some issues using Jumpstart. Jumpstart is a SageMaker functionality to use pre-built models, but I'm not going to use Jumpstart at all in this video, so we don't need to worry about this warning, okay? Um, cool. So now let's go ahead and use SageMaker to retrieve the current session and then to be able to access the default bucket. So from SageMaker, I'm going to retrieve the current session by invoking that function. Okay. And then I will be able to access the default bucket, like the bucket that SageMaker always has available in S3. Okay. And that's a bucket that remember I told you earlier that we need to have the data in S3 in a bucket that SageMaker can access. Obviously, the SageMaker default bucket in S3 can be accessed by SageMaker, okay? So this is a perfect bucket. And let's go ahead and store this in a variable. Um, this is the default bucket, but it's actually, let me just call it like this, SageMaker. You can use a different name, but I think this is a good name, SageMaker default bucket. Um, okay, SageMaker default bucket, and that's perfect, okay? Now, what I'm going to do is I'm going to use the S3 client that I created earlier now to upload the files. So we use the client to download the files, but we can use it also uh, to upload files. Okay, so S3 client, and now I'm going to use the function upload. Sorry, upload file because I'm gonna upload one file at a time. So we need to upload training, then validation, then testing. Okay. Um, Great. So three arguments. This function upload file takes three arguments. First, what file are you uploading? I'm uploading now the train.csv file. Okay. The second argument is to what bucket? To this bucket, to SageMaker default bucket. And the third argument is inside that bucket, define the path to that file. And this is something that you need to understand in terms of defining that path, guys. The standard way to store files in S3 is the following. So we have this structure usually. So we define a bucket, which we did, and then inside that bucket, we define a path to the file. Now, this path is usually divided in two parts. The first part of the path should be generic. What do I mean by generic? I mean that path, that generic path, should apply to any file that you upload to that bucket. You know what I mean? Like a generic path that applies to any file that you want to upload to that bucket. And then the second part of the path should be specific to each file. Okay, that's the standard way of storing data in S3, and that's the way that I'm going to apply right now. So a generic path followed by a specific path. So let's go ahead and define the path. Now, for the generic path, and actually for the specific path as well, but you have more freedom in terms of how do you want to call the generic path, okay? It's usually something related to what you are doing in your specific analysis. So here, how am I going to call that generic path? What am I doing here? I don't know, like I'm applying linear learner to apply a regression solution. So uh, maybe I can say something like, again, you have freedom here, guys. So linear, learner, regression. Okay, maybe you can actually even mention the data set that you're using. Okay, something like that. So that's the generic path. So in this bucket, the first part of the path is linear learner regression Avalon, and then the second path should be specific to this file. Isn't this the train CSV file? So I think a good specific name for that file is train, okay? Or you can call it train path, but I'm gonna just call it train, okay? And then you need to specify that inside that train, you're going to include your file, that CSV file that you are uploading, okay? Um, this should work. Let's run it, and it does. Okay, now we're gonna repeat the same thing for the other two files, right? So validation, validation file, the bucket, the first part of the path is generic, but then the specific part should be validation or something similar to that, and should be the validation.csv file. It checks. Good. Finally, test. Okay. Um, test. Um, then the specific part should be test and test. Good. That's excellent. So data has been uploaded to S3. Okay. Now it's time to define the model. Now it's time to define the model. Okay, and then later we train the model. Okay. So we're gonna define the model. So let me change this to text. And now we are defining the model. Okay. Guys, to define the model, we need to take care of two preliminary steps. Okay. First, and these are like mandatory steps, we need to define a location, another location in S3 for the model outputs. Okay, there are model outputs. Like once you train the model, there will be outputs that need to be stored. The most kind of the most important output that you need to know about right now is what they call the model artifact. Okay, so we need to define a location in S3 for the model outputs, the most again important and well-known output when you do a SageMaker training job is the model artifact. The model artifact is just simply a file. It's a file that stores all the parameters learned by the model. The model artifact also includes metadata that apps can use to refer to the model. Like, let's say you have an app that is going to invoke your model to make predictions. So for that app to invoke your model, that app needs metadata about the model, right? So that metadata is stored in the model artifact file, okay? And yeah, so it's mandatory to define the location to the output files, and so we need to do it. And the second preliminary step is we need to define a container to run the linear learner algorithm. Okay. Let's take care of the first step first, which is defining the location for the output files. Okay. I'm going to call that location output location, right? I think that's a good name. Actually, that's the usual name they use for the output files. Okay, you can use a different name, but I think it's a good name. Okay, sorry, output location. Okay, output location. Now, to define the output location, this is what I need to do. I need to combine because the output location will be obviously, well, hopefully it's obvious for you. So to define the output location, first we're going to define the bucket, the same bucket that we define here. Okay, but I need to combine the bucket, which is the bucket name, which is stored in this variable, okay? I need to combine that with a string literal that defines the rest of the path. So how am I going to do that combination? So I'm going to use an F string to combine the variable with the string literal, okay? So the output location obviously is going to be the bucket, the SageMaker default bucket, the generic path, because remember, any file in that bucket will be part of that generic path, okay? That generic path right here. And then a second part of the path, which is specific to the output files, okay? Cool. So let's use F string here to combine the variable with the string literals. So the path is S3. The first part of the path would be the um the variable, okay? Which is that variable contains the name of the bucket. Cool. That combined with a string literal. Well, this is also a string literal, right? So this string literal combined with this variable now combined with another string literal, okay? And then the next part of the string literal should be the generic path. Again, any file.bucket should be inside that generic path, okay? Now, obviously, we need to specify the second part of the path, which is specific. How do we want to call the second part of the path? Aren't we creating an output location for the output file? So I think a good name for that specific path should be output files. You can use a different name, but I think this is a good name. Okay, output files, and there we go. All right, perfect. All right, that's the output location. Again, mandatory to define a location in S3 to store the output files. The second preliminary step before we can define the model is to retrieve the right container for linear learner. Guys, remember that a container is kind of a virtual environment where an app runs, right? So any SageMaker built-in algorithm must run inside a container. Remember that in a container, you are able to, like if you want to run an app and that app needs other apps to be installed in the environment, a container can take care of that. So in a container, you can have all the dependencies that an app needs to get executed, right? So in this case, the app that we want to run is the linear learner algorithm, and it requires certain dependencies, certain operating systems. So the container for the linear learner app will contain all of that, okay? So how do we retrieve the right container for the linear learner app? We need to use the retrieve function from the image URI library in SageMaker. So in SageMaker, there is a library that allows us to use a function to retrieve whatever container that we need, right? So from SageMaker, specifically from this library, the image URIS, because we have a lot of images that we can retrieve there. From there, we can import the retrieve function, and that retrieve function will allow us to retrieve the specific container for linear learner or for any other built-in algorithm that we need, okay? So retrieve, let's invoke the retrieve function. This function takes many arguments, but mandatory arguments, 3. So first, what is the framework? So you can see the argument, you can see all the parameters here, okay? So what is the framework? You can name the arguments or not, but let's name it. What is the framework that you are retrieving the container for? Well, linear learner, right? Linear learner. Sorry, linear learner, okay? Then the region, what AWS region are you working from US East? But I remember I stored my region in this variable before, my region, remember? So can retrieve programmatically. And then the last mandatory argument is the version, okay? And I have always used this version number 1. Notice that the version must be specified as a string, okay? I have only used linear learner using version number 1. I'm sure there are other versions, so you can do your own research to decide whether other versions might be more appropriate for your specific case, okay? But I'm gonna use the one that I have always used, okay? And obviously I need to store this retrieve container in a variable, right? I should. So let me just call this obviously container and I guess linear learner. Oops, forgot the equal sign to the assignment. Good. Guys, we have completed the 2 preliminary steps that we needed before defining the model. Now we can define the model. To define the model, first you should use a name for that model. How do you want to call that model? I don't know you guys, but I think this name is pretty cool. You can have options here, but I'm going to call this linear learner model, okay? And maybe you can say linear learner model Avalon or something like that, but I think that's okay. So linear learner model. Now to define your model, you need to invoke the estimator function from SageMaker. Well, not only from SageMaker, from the Estimator library. So from SageMaker, you invoke the Estimator library and then the Estimator function, okay? And then you can define your model. So from SageMaker, you invoke the Estimator library. And then from the Estimator library, we need to invoke the Estimator function to be able to define the model. That will allow us to define the model. Now, that estimator function takes a lot of arguments. Actually, let me just do it like this because I need some room here. I'm going to specify only like the mandatory arguments, okay? The first one is, what is the container that you're going to use to run this model? And that parameter is image URI, and you know what the container is, right? This one. Okay, that's the first argument that we need to define. We need a role. We need a SageMaker role for the notebook to be able to initiate the training job. It requires a role that has access to S3 and to other apps in the background that SageMaker needs to initiate a training job. Okay, so we need a role, but you know, to define that role, all you have to do is from the SageMaker library get an execution role. So whenever you need a role to run a SageMaker model, this is what you're going to do. SageMaker get execution role. That's it. That will allow you to start the training job. Okay, but it's mandatory. It's mandatory that we define a role. Okay. Now we need to define things related to the instance, to the computing instance that we're using. Like how many instances do you want to use? You can use more than one, but in this case, the data set is so uh, small that I'm gonna only use one instance. Also, linear learner usually works fine with one instance. So, like if you want to know about what instance, how many instances to use for each SageMaker algorithm and what type of instance to use, you know, there is a whole world about this in SageMaker documentation. Okay, but trust me, in this case, given the data set and that we're using linear learner, one instance is fine. The other thing is that you must define the instance type, guys. You know, again, just like a full world behind instance types, okay? Like deciding the best instance type of all of that. I'm going to use the instance type that I have always used, a machine learning M4 large instance, okay? M4 is one of the many computing instances in SageMaker. So in SageMaker, or in AWS, actually, in AWS, we have CPU instances and GPU instances. The M family is one of the families of CPU instances, okay? And again, I have always used, whenever I run either linear learner or XGBoost, I always use that instance type, okay? Again, if you want to know more about instance types, feel free to do your own research, okay? But for this demo, I just want to use that one, okay? We need to define a parameter that is output path. What do you think the output path is? What do I mean by output path? Is the path in S3 for the output files. The path in S3 for the output files. Do we have that defined? Yes. The output location. Okay. And the final parameter we find here is a session. So for this notebook to run, it must run inside a session. Okay. So we need a SageMaker session. And you know how to retrieve a SageMaker session, don't you? SageMaker session. To retrieve the current SageMaker session, remember that we can do SageMaker dot session, right? And that's it. That's all we need. That's what we need to define the model. Okay. Well, we need one more thing, but for now, this is all we need. So let me run this to make sure it runs correctly, and it does. The last thing we need to finally define the model is to set a group of basic hyperparameters, okay? And that's what I'm gonna do now. I'm gonna show you how to set the most important hyperparameters needed for a regression solution when you use linear learner, okay? Let's go ahead and do that. All right, so let's set the hyperparameters for this linear learner model. So for that, I'm gonna use the function set dot hyperparameters. Okay, so forward hyperparameters. And now we need to pass a few arguments to this function, okay? So this is what I'm going to do, guys. So I'm going to set specific values for the three most important hyperparameters for a linear learner regression solution. So the most important hyperparameters for linear learner for classification and regression are not the same, okay? But here we are focusing on a regression solution. So based on the documentation, the three most important hyperparameters that you need to set are the weight decay. Weight decay is just simply the penalty value for the L2 regularization. Okay, that's one. The learning rate. So in the background, linear learner applies gradient descent. So there's a learning rate involved. And learning rate is just simply let's say the step used by the optimizer in between model parameters updates. Okay, like in between model updates, that's the step used by the optimizer. That would be the learning rate. Right, that's a very simplistic definition. So weight decay, learning rate, and batch size. The third important hyperparameter for regression is the batch size. That's just the number of observations used to perform each model update. Like after how many observations, so we see a model update, okay? All right, so let's go ahead and do that. Before setting up these three hyperparameters, we need to define a couple of hyperparameters. First, the feature dimension, how many features? 8, right? Remember? So 9 columns, but 8 of them are features. What kind of predictor type we're using? So are we doing regression or classification? Regression, right? So the predictor type is regressor. And the next one will be, close this quote. The next one will be the loss function. What is the loss function that we're going to use for regression? The most common, not the only one, there are a couple of available, but the most common one is square loss. Square loss is just simply MSE, mean square error, plus the penalty values, okay? Cool. Now let's go ahead and set up the three hyperparameters that I mentioned. The first one is WD, weight decay. Now, for weight decay, guys, the recommended range of values is between 0 and 1. And what you should know is that the closer to 0, then the less regularization. So the closer to 0, the value that you choose, the less regularization. And obviously, the closer to 1, the stronger the regularization. I'm going to use 0.01, which based on what I have read about linear learner and a few sample notebooks I have inspected, 0.01 give us kind of a good balance between too much regularization and too little regularization. Okay, obviously you can try different a different value if you want to, but I'm gonna go with that one. What's the other one I said? Learning rate. Okay, so learning rate. The learning rate is any value in between 0 and 1, and usual values are um, between 0.1 and 0.5. Okay. So I'm going to use 0.1 because, again, you can try something different, but 0.1, it's a kind of quite a small learning rate. Not, it could be even a smaller, but I think that they give us a good balance. So to avoid the model to avoid the model from learning too fast, if that makes sense, okay? So in certain cases, you might even need to use 0.01, might be a better option, or even a little bit higher, 0.3, okay? But yeah, I'm gonna go with 0.1, okay? Feel free to try something different. And the last hyperparameter is batched size, which is actually named here mini. Batched size. What's the deal with mini batch size? Well, this is just, guys, as I told you, the number of observations used to perform each model update. The recommended values here are between 100 and 5,000. Now, remember, our data set, our training data has 2,900 observations. So let's say 3,000, okay? So 3,000. The usual recommended value is 1,000. Again, recommended values between 100 and 5,000. Usually 1,000 is a good balanced value, but 1,000 it's too large in this case because 1,000 it's almost it's actually a little bit more than 1/3 of the training data. It doesn't make sense to use a batch size that is a little bit more than 1/3 of the data set, right? Of the training data set. So I'm gonna go with the minimum recommended value in this case, okay, 100, all right? Again, feel free to try something different if you want to, okay? And yeah, that's all. And guys, we have officially defined our model. Now let's move on to the next step, which is train our model. So let me specify that now we are training the model, train the model. And now before we can actually train the model, which, to train the model, all we have to do is invoke the fit function on the define model. Before doing that, we need to define the data channels. That's another mandatory step. Before feeding the model, you need to define the data channels, and we need to define two channels. It's mandatory to define two channels: the train channel and the validation channel. Now, what is a channel? What is a data channel? It's kind of a way for us to formally define the location of the data in S3, okay? Now, to make that definition formal, we must use a specific SageMaker function, training input. So we use the training input function, and that will allow us to formally define the location in S3 of our data, of our trained data and validation data, okay? All right, so let's go ahead and define both channels. So first, the train data. Let's call it channel, why not? Train data channel, okay? And I told you that we were going to use the training input function, right? The training input function is actually part of the inputs library, okay? From the inputs library, we retrieve the training input function, and that's the function that allows us to formally define the location S3 of our data, okay? Here we need to combine again the variable where I stored the bucket name and then string literal. So we're going to use f string again, okay? So because remember the location? Remember the location of the training data? So it's just the data bucket and then the generic path and then the specific path, right? So anyway, so let's combine all of that with an f string. Sorry. I'm going to go ahead and actually close this here. So the first part of the path in S3 is just simply S3 colon / then we need 2 /. So we need first the bucket, which is the bucket is the bucket where the data is, right? Sorry. Here is where we uploaded the data, right? So SageMaker default bucket, okay. Yeah, the first bucket was the bucket where the data was originally, but the data is now in that bucket. And yeah, guys, so what is the rest of the path? Let me just go ahead and copy that here from here. Isn't this the path? Linear learner, regression avalon, the generic path, and then train and train.csv. Yes, it is. And there you have it. So I'm just gonna paste that there. Does that look good? So S3 in that bucket, linear learner, avalon train.csv, and yep, that's the train data channel. Okay. One more thing, almost forgot. The training input function requires us to specify what content type to expect in that file. So that's a CSV file. So for the CSV file, the content type that you should specify is So whenever you have a CSV file, this is the content type you're going to specify. Text, CSV, okay? That's another mandatory parameter to define, okay? And let's run this. And it works. So I'm gonna actually copy these guys and define the validation data channel. It's very similar. So instead of train, I'm gonna call it validation, and what do I need to change here? The bucket name is the same one. The first part of the path is generic. Here it should be validation. Here it should be validation. And then the content type is the same. By the way, you don't need to define a data channel for the test data. The test data is it's available there for you to make predictions on that test data if you want to evaluate how well or poorly your model does with unseen data. Okay, but you don't need to create a a test data channel to train the model. To train the model, we need train channel for the train data and the validation data, because as you'll see, with the train model, we are going to be able to get performance metrics on the validation data. So that's why we need the validation data. We need the train data, obviously, to train the model. But why do we need the validation data? Because as you'll see later, we'll be able to get, for the final train model, performance metrics on the validation data. And okay, let me check. Yeah, it's good. And now to create we need to combine both data channels in a dictionary using a specific key. So we need to use the train key for the data for the train data channel and the validation key for the validation data channel. Okay, so that's another requirement. So you combine both channels in a dictionary. How am I gonna call this? How about data channels? I don't know. Maybe I call it like this, dictionary. I don't know. I think, or you can use a different name. Again, it's up to you. Maybe you call it just simply data channels. I think that's okay. But I'm gonna call it data channel dictionary, and it's a dictionary with two keys. The first one is the train channel. What is the train channel? Well, this is the train channel, and the other key is validation. Um, Validation is the value for that key is the validation channel. Okay, that looks great. Now we can actually finally go ahead and train the model. And to train the model, all we have to do is do the following: invoke the fit function on the data channels. Okay, data channels contains the path to the train data and validation data. Should be part. Let me make sure I get this right. So data channels should be passed as an argument to the inputs inputs parameter. Okay, so the inputs will be drawn from the data channels dictionary. And one thing that I'm going to do, guys, I'm gonna set logs to false by default. Logs is set to true, but if you leave it like that, like by default, the default, which is logs to true, you're gonna get a huge list of a lot of login information, which I don't want to see. Okay. Um, okay, so let's go ahead and run this a training job. It's gonna take like around 5 minutes, so I'm gonna run it and I'm gonna pause the video and resume after the feed is done. Again, it's gonna take around 5 minutes, no more than that. Okay, so let me go ahead and run it. Notice that it's letting us that this is letting us know that the training job is being created. The training job started. Okay, so again, it's gonna take like 5 minutes. I'll be back when this is done. All right, the training job completed. As you can see here, initially, actually, it failed. The training job failed because I made the mistake to, like here, instead of size with a Z, I use an S. So, gave me an error. I fixed it and run it a second time. And Then the training job completed successfully, okay? All right, so to wrap up this video, what I'm going to do now is I'm going to use this model and I'm gonna retrieve performance metrics for this model on the validation data. How do you do that? How do you retrieve performance metrics on the validation data? On that model, you can invoke the property latest training job, okay, latest training job, and obviously you should store this in a variable. Um, how am I gonna call this? I don't know how to call it, but I guess I'm just gonna call it like this train model metrics. How about that? Okay, train model metrics. Um, and well, that's not that because here I'm not retrieving the metrics. I'm just retrieving the final training job. So train model, just let me just call it train model, okay? Because I think that's a good name, train model. Yeah, here we don't have metrics yet. To retrieve the metrics from the model, we need to do something else, okay? Um, okay, so train model, actually, if you try to inspect what is inside this object, you are not able to retrieve anything. So we need to use um, specific function on this object to be able to retrieve the metrics, okay? And that function is, this is something that I always forget, so that's why I store it here. This function, guys. So we need to invoke the describe function on that object, and specifically, we need to retrieve this key, final metric data list, okay? Let's go ahead and do that, all right? So, so we can say something like trained model, and then on that trained model, we invoke this. And as you will see right now, what is this final training data list? Well, linear learner in the background trains many models, not only one. Like it does it in parallel, actually. So it trains many models in parallel, and with each model, linear learner is trying a different hyperparameter setting. And what linear learner does is it uses the validation data set to select among all the models that it tried the best one. Okay. So here, by doing this, we are able to retrieve the metrics of the selected best model after the training job finished. Okay. So these metrics will be the metrics of the chosen model. What is the chosen model? The best one, that the model that performed the best on the validation data set. Okay. All right, I think um, I mean, we can just go ahead and run this and see the output, but maybe we want to store this in a variable so we can refer to that later if we need to. I don't need to do it right now, but I think it's a good idea. So training model, and here we can use the word metrics, okay? And sure enough, guys, this is what we see. There you have it. Okay. These are validation metrics, performance metrics on the validation data set, okay? For example, and again, for what? For the best model, for the chosen model, okay? The performance metrics of the chosen model on the validation data set. So we see the absolute error, sorry, yeah, absolute loss, absolute error, same thing. Absolute loss is MMAE, so the mean absolute error, okay? Same thing. Different name, but it's the same thing. The absolute error of on the validation data set. We also see the objective loss. Remember, the objective loss is MSE plus the penalty, okay? 5.39. Training progress, 100%. The training is done, so 100%. We see the MSE, very similar to the objective loss, okay? 1.37, that's the validation MSE. But remember, objective loss is MSE plus the penalty. And so on and so forth, guys. So we also see the validation MAE. So that's mean absolute error. It should be the same as absolute loss. Yes. Notice that how the absolute loss 1.6417 is the same as MAE. MAE is just the mean absolute error. Okay, same value. Okay. We also see the RMSE. Nice. That's a nice metric. And think R square also, yeah, R square is also available. Okay, so what do we do with this information? So with this information, we can evaluate the quality of the chosen model. Is it a good model or not? I don't know. For example, like R square seems to be a little bit low. So let's say 51% if you round it to two decimal places. So 51% R square. There is room for improvement. And what else? So for example, another thing that you can do is RMSE. You can use RMSE. RMSE is um, more or less, not exactly this, but more or less, it tells us by how much the predicted values of rings deviate from the actual values of rings. Rings, remember, is the target value, right? So RMSE tells us like by how much um, um, the predicted values of the target deviate from the actual values of the target, okay? So how do we know if that deviation is low or high? You know, low means good, high means bad, right? Because we want a low deviation, like a small deviation, right? Small deviation between predicted and real values. How do we know if that deviation is small or high? Well, we can compare that deviation with the mean of the target. The mean of the target is the mean ring. So you can compute the mean rings, and then you can compute what they call in statistics a coefficient of variation, which is uh, the RMSE divided by the mean of the target, okay? And remember, with that coefficient of variation, we are aiming for less than 20% coefficient of variation. So that gives you, like, if the coefficient of variation is less than 20%, that's an indication that the model is acceptable. Ideally, we want coefficient of variation less than 10%, okay? But my point is that, you know, using RMSE and R square, you can get a good idea of how good or bad this model is in terms of predictive performance, okay? Cool. Now, the last thing I want to say is this part. Remember, I wanted to mention, not demonstrate, but mention how to deploy the train model to an endpoint. So if you want to deploy this model to a SageMaker endpoint, and then being able to send new data for prediction to this endpoint, because once you deploy the model to an endpoint, then you can send data like apps. Apps can send data, like the test data, for example. We haven't used the test data. So we can send the test data to the endpoint and get prediction for that test data. But not only this test data, also new upcoming data. So you can deploy the model to an endpoint and then send data to that endpoint for predictions. To do that, you do something like this. I'm not gonna do it. I'm just gonna show you. You get the model, okay, the model that you train. Actually, I'm gonna kind of include this in a comment because I'm not gonna run this. So, and on that model, you will invoke the deploy function with a bunch of hyperparameters that I'm not gonna cover right now, but you invoke the deploy function, and then what you should do is you should store that in a new variable because you want to be able to retrieve to the deploy model, right? So once you deploy the model, you should store that in a new variable that I like to call always like that, and then I like to add the word deployed, okay? Linear learner model deployed, okay? And again, you need to pass a few arguments here that I'm not gonna discuss, but that will give you a deployed model, okay? And then again, after that, you can send predictions to the deployed model. All right, guys, so that's all I wanted to cover in this video. I hope you learn how to fit a regression solution using SageMaker Linear Learner. And I might do a different video showing you how to do the deployment, but you know, that will be a different video if I decide to do it, okay? But yeah, so again, hope you learn a lot, and I will see you in another video. Bye, guys.